Hello. Hello, everyone. So guess what I did? I was a little late, even for my 8:45 start time. But I came on, rushed, did it, pressed the button, started talking, probably for like 15 minutes. I was going in and I was going through the lessons. I probably did the first two PowerPoints, went through them, was hitting all the good stuff, hitting all the high points, going over the test, good stuff right that. And guess what I didn't do? I hit the button, but apparently not hard enough to start the stupid live stream. Can you believe that? This guy is a stupid idiot right here. I'm pointing to me if you couldn't tell. If you're listening at home, yeah, I cannot believe I did that. I was talking for a while, like way too long for me to not have noticed. Um, like way too long for me to not have noticed. Wow. Okay. Um, so I was pretty wow. It's been like, and then I had to figure out what was wrong with why I didn't do it. So that took me another 10 minutes. But it was probably legitimately 15 to 20 minutes of me talking with no one listening. Wow. And I was getting a little mad at the lack of feedback. I was like, geez, I'm teaching up a storm up here. Wow. Okay. Anyway, again, now it's even later than I even like way later than I even wanted it to be. But hope the mic is working now too. Ah, way too many problems. Am I gonna have to do this again? Can people hear me now, actually? That would be super great if people could hear me. Um, please say something that you can hear me. Or just, okay, I wasn't saying anything then. Okay, people could hear me. Alexis commented. God, cannot believe how dumb I am. Okay. I was like approaching being done. I was like, oh, we're good. They got it. No questions. Good. Um, yeah, good. All right. Dang. Okay. It's this. I swear they change YouTube all the stinking time, right? I had to hit start on this and two things this time. It's like, come on, YouTube, step up your game. And why didn't YouTube tell me I wasn't talking to anyone? All right, compose myself and let's jump into it. Let's just dive into it. Um, and again, sorry that it's so late, but again, the good news is there's an extra day, so you can always go back and watch it tomorrow and just pretend that I was live. Like I was pretending that I was live, just like that. It'll be even. Mm. Okay, here we go. All right, I'll just pretend like I'm starting. Okay. What's up, guys? It's your boy M Spitz coming at you live. This is the first time I did this. I didn't make any mistakes before. This is smooth sailing, just like I normally did. All right, great. Here we go. So as far as we have a great, glorious test 2 days hence this moment. I got the energy going. We're good here. Great, great, amazing things here. Okay, yeah. Anyway, so if I'm looking and I'm just running through, I'm gonna sort of do this a different way than I did before. I'm just going to give you sort of the general topics. Stop me if there's questions on those topics, um, like the topics of sort of questions and stuff, sort of as we go through. So it's less general than I did last time, but it hopefully she'll be. I mean, I didn't do one last time. That's ridiculous. Who would have done that? Um, okay, so it's like we've talked about sort of algorithm. I mean, the whole thing is about algorithms. Like an algorithm, again, recipe for doing something. And algorithms that we're talking about more in depth are searching and sorting algorithms, right? So we've talked about searching. There's two different types of searching algorithms that we use just generally. Sequential, which is also called linear search or sequential search. And all that does is go through every value in the list. And again, I actually had this one up already. I mean, I'm just gonna stop pretending. Okay. So see, I had them up. Look at when I 24, 6, look at all these. Look at these times. It's like okay. So searching algorithms. Yeah. All right. Anyway, so searching algorithms. Again, there's main things when we're talking about algorithms in general. We look at the sort of three factors, and again, there's correctness, clarity, and efficiency. And we want to sort of think about the efficiency as the speed that it's going to run, but also the space that the computer space that it's taking up. Right? It might use more RAM, might use more CPU cycles, it might take up more. I mean, those are the two main memory. Like that's the two main things that you're going to talk about: memory, which is RAM, and your CPU, right? Those are the two main things you could sort of, if computer resources it could use up, but also your resource or the resource of time, right? So those are the efficiency of it. Is it good with time and computer, your computer resources? Um, but of course, sometimes what you lack in efficiency might make up for it in clarity or correct, or hopefully correctness. Hopefully everything's correct, otherwise you wouldn't use it probably. But what might make up for it in clarity? Maybe it's super easy to use. I think linear search is one of those examples. It's slower than a binary search, but it's pretty clear. It's easy to understand. So, um, so if something runs slow, it's like, yeah, yeah. Well, there's other way. There are ways to figure that out. Maybe we could figure out a different way to deal with that. All right. Okay. Um, so okay. So yeah, I'm gonna be more general. I can't do this again. Sorry, guys. Anyway, I just can't. But for our questions, I'll be happy to take them. Maybe that's just a better way to do it. All right. Let me just go through. I'm gonna go through a little faster. All right. So we'll start at the top here. Um, so we're talking about again, we're talking about algorithms. We're talking about maybe processing. That's just processing or dealing with data, right? The thing is the things that would affect um, how this would be able to be processed, right? Would be like if it takes a long time to run, or how much computer space. So I'm sort of starting from the top here in a little more straightforward manner, right? So anyway, just so we're aware, okay. But how much space it takes up, how much the memory, which is the RAM, that it takes it to run, and sort of how long it takes to run. So we sort of are good. That's how sort of efficient. That will affect sort of the ability. Those are the things that affect its ability to run. Um, we're talking about binary search. We do know that binary search would be good for things that are in order, right? So if it only works, a binary search only works for things that are in order. Again, I think I said that about 100 times, um, and like 50 of those times you could actually hear. So binary search, right? We know that a binary search starts in the middle, right? And then if the list is in order, and you say that, oh, it's not that value, but it's less than that, now we have a range. I guess it would be over here. We'd have a range that now we have a new list that's shorter, and then we pick a value in the middle, and then it's on this side of it, so we just eliminate half it, and then it sort of narrows it down by half at a time. So it ends up being like a logarithmic shape, which is a little bit less steep. Actually, it's a lot less steep than like a quadratic graph, n squared graph, which would be like um, sort of another type. Well, but it doesn't. The idea with binary is that it's like you can double the amount of guesses that you take, but only reduce the or only increase the amount of guesses you would have to make by one every time you double it. So it's a way more sort of efficient with time, right? Um, and so, of course, things would have to be in order for you to do a binary search on them, right? And of course, they could be in, whatever they happen to be, right? If they're words, they should be in alphabetical order. If they're numbers, they should be in, some sequential order that it makes sense to eliminate half of the words or not, right? Or half of the words or numbers or lists or whatever you're doing, right? Whatever you're trying to search through, okay? Um, all right. And then sort of on the other side, right, we're talking about a sequential search, right? What would be like that one just what a sequential search is, it just looks to see if what you're trying to find is the thing that you're looking for. So if you're looking for a specific name in a catalog or something or a item, it's just going to look through and see if it's there. And if it is, it stops and it says, yep, it's there. It's at spot number 15 or whatever it says, right? But it's gonna just look through them individually. And of course, that really works well if you're talking about things that aren't necessarily in order, right? Um, so again, it would be most useful in something that wasn't in order, that wasn't in any particular sort of order that would be easily searchable, right? That would be easily in order. So if it, like something was definitely not in order and there's like a bunch of stuff that wasn't in order, yeah, you just want to go through them one by one and just see if it matches, right? So if you're going to look up something like that, that would be the sort of the better way to do that. Um, we talked a lot about code as far as dealing with lists and going for each number in every lit in each list and sort of going through um, what the values would be and how we would sort of yeah. Anyway, so the idea would be that we did a lot of stuff with that with our list of lists app inventor, which I might still have that pulled up here maybe. Yeah, so our list of lists again it might look slightly different, but we talked about having parallel lists um, or lists that sort of correspond with each other, with their indexes correspond with one another. So yeah, we talked about that. Um, what else did we talk about? Again, the idea with algorithm, again, we talked about the limits of them just generally, but we'll come back to that. But um, right, if you have a problem that you can solve, right, that takes too much time. We talked about intractable problems, and again, I can cover that in a second. But um, let's see, the three types of sorts that we did, right? Were bubble sort, which you should definitely know all the steps to bubble sort. There's a great links in there. There's actually it walks through it pretty well in the PowerPoint. It's probably like 40 slides that walk through bubble sort exactly how it happens, which things swap, how it orders. So if we're talking about ascending order, you know, it would put the highest number, it would bubble the highest number to the back. It would change other things along the way as well, but it would bubble the highest one to sort of the to the top basically of the list, the right side. I'm doing left because it's reverse, but boom. And then it's my left. Anyway, but if it was ascending or sorry, if it was descending order, then it would bubble the lowest one to the top there. Um, but the point is that there's a lot of that there are a point is no matter what algorithm you're using or choosing to use, there's sort of upsides and downsides to them both. Right? There are drawbacks and upsides to anything you use, whether that's because it's more easy to understand, has higher clarity, or um, or if it just uses fewer resources. Like even if you look at the graphs of like our sorting algorithms, which are here, right? And again, I'm just going to use this as an example. But here's the bubble sort that I was talking about. It's like all there. It's like a lot of slides, but it does walk through step by step individually. But if I'm looking at like all three graphs together as far as the sorting goes, it's like yeah. So bucket sort, right? This is bucket sort is the purple. It's going to be the most sort of efficient time wise, right? Um, and I can do that with you know all the same types of data you can deal with. But it actually does, one of the downsides, again, if we sum up at the bottom, bucket sort uses more memory, right? It has to make individual buckets for every sort of category, and every category of numbers that are in there, which could be millions of categories possible. It has to make the buckets themselves sort of take up way more memory. So merge sort also uses more memory. While both bucket and merge are way faster than bubble, I feel like bubble is pretty easy to understand, and it doesn't use that hardly any memory at all because it's just swapping individual values in there. Now what it does use is more time, right? So it takes more time, but uses less resources. So yeah, and also it's easier to understand, I think. Um, um, Yeah, we talked about certain the limits to algorithms. Of course, there are algorithms that, or there's problems that we can't figure out with algorithms, right? Um, and again, undecidable problems are some examples, or some undecidable problems are actually all undecidable problems are examples of that, right? You can't. It's possible that there aren't any, yeah, you can't get. Sorry, undecidable problems basically are problems that you can't get a yes or no output for every time, right? So so of course there are problems that so those are the types of problems I should say that you can't have an algorithm that doesn't really work for that. It doesn't solve that. Let's see. Some of the things we talked about. Let's see, where is it? Limits, right? Again, I think I was already there. So undecidable and intractable problems are two types of problems. The main thing with intractable problems is, go to this one, right? Is that intractable problems are kind of can be useful. In like you'd want a problem to be intractable, like or the fact that it is intractable is kind of a good thing. Like if you guessing a password would be an example of that, where yeah, we want it to be there's only one solution that works for the password, right? And you could write an algorithm that just checks every single possible password there is. That would take forever, but it would still work, right? It would eventually work, right? So that's kind of a good thing. It sort of helps with cryptography and sort of computer security and password protection, right? That's what we use them for. That's a good idea. So that's what an intractable problem is. It's like yeah, we can get there eventually, but it's going to take so long to get the optimal answer that it's just not worth it. So what we end up with is heuristic algorithms that are used to sort of solve intractable problems. And I'm putting solve in quotation marks because what a heuristic algorithm does is it's basically saying, you know what, we're going to use this algorithm that's going to help us find. It's good, sort of. It's much quicker than going through every possible solution and finding the optimal one. Even though I could find the optimal one, it would take too long. So I'm going to use this heuristic algorithm, which sort of gives us a good enough answer quickly, right? So it gives us a good enough answer. So they're useful. Heuristics are useful um, when exact values aren't necessary. Okay, when when good enough is fine for that particular um, problem. Um, let's see. So that I mean that is if you know those things, you know those things well, and you know that bubble sort makes a lot of comparisons between numbers. That's sort of how it works. It compares two numbers and swaps them, or it doesn't. While merge sort doesn't make a whole as many comparisons, but it uses more space because it sort of goes from a list of 16 individual lists, let's say if there's 16 values, to 8 lists of two, right? To 4 lists of four, to 2 lists of eight, eight. There you go to sort of one list of 16. So it's merging and merging and merging them together. That's why it's called a merge sort. And of course, bucket sort. I talked about that a little bit already. Oops, I don't have the comments up anywhere. Hopefully, you guys aren't saying anything. Nope. This is just like when I was saying it before. So, see, I could be talking and talking and talking, and I wouldn't even have known because there's no questions. Again, I'm not going to answer the blown away stuff in there if there's going to be that stuff on there. Right? I sort of meant I didn't mention it, but again, the idea is I don't know. Like, I'm not going to answer what's going to be on the test, so I'm doing a pretty good job of that already, actually. Um, so yeah, I mean, really, there's not a ton of stuff. If you're really familiar with like the main ideas and the things that I've been repeating, if you listened in class, there's not a chance you could if you've listened to what I've said in class and like the things that I've repeated like over and over again, those are the main topics. Of course, you have to take that information and apply it to certain situations. You just have to, right? So, it's not gonna be like, what's an intractable problem? Actually, to be honest, there's some vocabulary on there, so that could be on there. I don't actually remember the exact vocabulary, but you should know the vocabulary, right? But in this case, there's no list of vocabulary. It's just throughout the PowerPoints. But the idea is that yes, so while there is vocabulary, there's of course the multiple choice questions, which will involve like more than that. Of course, they're going to involve like you know knowing what the things are and then applying that to a situation. You know, stuff like that. So again, if you're familiar with those types of sorts that we've used, those types of searches, what their pros and cons are for each of them, you should be good. You should be great even. All right. Is everyone okay with that? Any questions, comments, concerns? All right. So people can at least watch it next time, or they can watch it tomorrow. Not that I did a whole lot. I did technically go through, like, if you were, go through the concepts, pretty much all of them. Again, you're gonna have to apply them still, so it's not like it's just somehow gonna be exactly what I said there. There are certainly some vocabulary. Again, there isn't those, but you should sort of know. They're probably. I think most of the vocabulary is in the algorithm limits, right? Because again, there's brute force. I mean, actually, I don't know if this is even an algorithm, but my point is that there's a lot of vocabulary in this. Not here. This one, the limits of algorithms, because it talks about heuristics, talks about intractable problems, undecidable problems. It talks about sort of the types of. Um, oh, you know what? There's one more presentation that I didn't actually even talk about. So that might be a good idea to look at there. Because the last one is the debugging one, which is at the bottom here. So the debugging PowerPoint is about sort of, again, we talked about the, I almost missed that. What the process of debugging is, what syntax are for semantic errors, what would an example of those would be in App Inventor, and then the tips for debugging, and then sort of we talked about where debugging came from a lot. There's the bug. Um, Anyway, so again, that's a shorter one, but it's still don't forget about it. Let's see. So yeah, you check the PowerPoints for the vocabulary is what it comes down to, and then you should be able to, you know, nothing else is too crazy that I already did mention. So again, I don't know where other people are. I think I'm gonna make it private. I am annoyed that not everyone showed up. Should I just make it private? Yeah, I think I will. Anyway, I spent all this time here. Oh, so okay. So Tyler, what App Inventor, like what would you like to know about the App Inventor code? I mean, okay, let's put it this way. What was the main idea of the quiz app that we did? And the main idea of the drills that we did? It was lists, right? I mean, it was lists of lists. So it was sort of iterating through a list, being able to understand what an index of a list is. But those are things that we even talked about before mostly, but those are the main ideas, right? Having concurrent or parallel lists, right? Also the idea. So without going through the specific the specific code, because you're not gonna have to code anything specifically. You should know what the sort of the main ideas are, and that's pretty much what we're gonna have to know, right? You're gonna have to know lists about lists and indexes and what item versus the index. Making loops for each item in the list type loop or a for loop that goes to the indexes. Again, we did a lot of that, but those were the big general terms. Again, if not just you, but if you were in class and sort of following along, and it made sense as we were following along, and we sort of see what I was doing, like you should be fine with that. Like there's right, and honestly, that's what it comes down to. If you're even 80% listening in class, like you'll be great on this. If you're not, then you might not be. And there's only 2 tests this semester, but I won't worry too much about it. You should, but I won't. What else, people? I think that's about it. Again, I know. I'm sorry for being later. Maybe that's why it's being later. So I'll leave it up for tomorrow, I guess. It's not like I did a whole ton. I could do better. I could do better, people. But anyway, I'm gonna go to sleep now. Probably not for a while, but I'm gonna leave now. So again, sorry I was a little later, but again, I wanted to get something up for you guys. And I know I didn't get a ton of questions and stuff as before, but I kind of get it. It was late. It was not quite the stream that I was supposed to be. I just don't think I'm going to be able to do it tomorrow. If somehow miraculously I end up getting home on time or something tomorrow and I can do it, I might. But yeah, the third time's a charm. So maybe I'll maybe that'll be it, but probably not. All right. I will catch you on the flip side, people. Nah, that's lame. How about just edit that out? I'll edit that out in post. Alexis, do you need me to say anything right now on the live stream to make your video? I'll just do it right now. If you give me a script, I'll read it. But other than that, I'm going. All right. Anything in particular that you want me to say? I'll wait for you to think of something. Say something funny. Like, how funny? Can I write on this? Wait, hold on. That wasn't funny. That wasn't supposed to be. Um, what's tag out mean? Is that a cool term I don't understand? What if I said beebadee badee badee badee? That's all, folks. I don't know. Comp. See you later. Boom. I don't know. Cannot believe I did this stream twice. It definitely got less good the second time. Sorry, guys. Man, I was killing it the first time. Ugh. I cannot believe how big of an idiot I am. Why would I have done that? Anyway. See you guys. Bye, everyone. Thanks for coming. Sorry it was so late. I'll do better, just like I'm sure you will in class. Anyway, you're the best. Even if I get mad at you, I love you guys. You're all great. Tell people to slap like. I don't know what that means. Hope that's not bad. Slap like? I still don't get it. That's alright. Anyway. Oh, I get it. Slap the like button. Don't forget to like and subscribe. Make sure you know what? Tell me your favorite color in the comment below. Always ask some ridiculous question and make them comment in the comment section below because I really want to see your comments. So make sure you comment in the comment section below. Slap that like button. Notification bell comes up. Click all the things on the notification bell to make sure you don't miss content from this content creator. Make sure you follow me on Twitter and Twitch and Instagram and Yelp and LinkedIn. Okay, and my TikTok and all the other things, all the other social media garbage that there is. Follow me, like, subscribe, tell your friends to like and subscribe, hire Russian bots to like and subscribe, view it more than once, 3 times at least, comment your favorite color, your favorite animal, and your favorite food, but also how you feel about the War of 1812 below, so I will read it. Um, I'm doing a giveaway of a Starbucks card that has $2.37 left on it from the random comments below. But you got to be subscribed. You got to like. You got to comment. You got to also like on my Twitter and my Twitch and Instagram. All those things. Then I put them into a contest and you get drawn out and then you'll get it. Believe me. Yes. This is brought to you by NordVPN. Right? Probably something like that. NordVPN. Buy my merch. And that's it. Is this my end card? Can I say all that stuff on my end card? that a thing? End card? I don't know. Boom. I'll see you guys. I think I got it all.